Hello and welcome back. This is part 6 of a series covering the Hare programming language, and in this video I would like to take a brief detour from the official tutorial and introduce you to two language features that are going to be essential when we come to error handling with pattern matching, and those are assertions and tagged unions. In this way, when we get into error handling, you're not being introduced to multiple new concepts at once. And so hopefully this is going to kind of cut down on the cognitive load, and that way you're not trying to, you know, grasp multiple new concepts at once. And that way you're not trying to sort of debug the language, you're just trying to understand one thing at a time. So here is an example of a simple runtime assertion. Now, assertions, if you're not familiar, assertions are basically a way to evaluate a condition within your code. Okay, so let's go ahead and look and see what's happening here. We just have a basic let binding. This is foo, and we're just assigning it a value. Now here is our assert statement. And what this is going to do, it's going to evaluate this expression. And if this expression returns true, then our code will continue to run normally. Our program will continue to execute. If this condition evaluates to false, it's going to return that to assert, and it's going to terminate our program and print out an error message for us. Okay? Now, you can see in this example, we are asserting that foo is 42 at this point in our code. So this program will continue to run. So let's go ahead and look at that. And you can see that our program did indeed run. There's nothing being printed here, so you're not going to see any output to the console. Okay? Now, let's go ahead and jump back into our program, and let's go ahead and try a different condition. Let's just say what I'm trying to do is I'm trying to trigger this assert statement. So I'm asserting that foo is 40, and you can see that it's 42. So this time this assertion is going to trip. And you can see that the assertion did indeed fail. So it aborts our program. Here is the file, the line, and the column number. And you can see assertion failed, and it has the assert statement here. Okay, so that's what an assertion does. It asserts that a condition is true or false. If it's true, your program continues to run. If it's false, it terminates your program with an error message. And these are good for enforcing invariance in your program, right? If you need a certain condition to be true at a certain point in your code, you want to use assertions. Now, there was a very good talk that just came out a few days ago by Herb Sutter, where he talks about assertions and how important they are. So don't be afraid to litter these in your programs. Okay, these are a good way to catch errors. Okay. Now, this is a runtime assertion. It's being evaluated at runtime. Okay. The other form of a runtime assertion is with the const keyword, because const is a runtime constant. You can put user input in here, for example. Okay, so let me go ahead and just replace this, and this will run just fine. Let's look at an example of that. and you can see that it indeed did run just fine. And I will just go ahead and trigger this runtime assertion using const. So this is an immutable value, but this is going to be evaluated at runtime. Okay, so when we run our program. And you can see that it triggered the assertion, okay, just like before. So here's our assert message, the file, and the line number, and it shows us exactly where the assertion failed, okay? Now, let's go ahead and look at a different example. And we are going to look at a compile time assertion. Now, this is an assertion that is evaluated when you compile your program rather than when you run your program. So there's two states to your program. There's compile time and then run time. So in order to evaluate a compile time assertion, the variable has to be defined with the def keyword because that is a compile time constant. So let's create a compile time variable. We'll say foo, and it'll be type string, and just something simple. So hello, okay? Now, in order to use a compile time assertion, we have to use what's called a static assert, okay? So this is going to evaluate whatever condition we place here at compile time rather than runtime, okay? Now in this instance, let's use the built-in len function, and let's assert the len of foo is greater than 0, which it indeed is, you can see. So we're just using the built-in len function. That was introduced in a previous video. You can get the length of strings or any collection type, arrays, slices, and also strings, okay? So here this is a compile time assertion. We have foo being defined with def. We're using static assert, and we're just asserting that this is not an empty string, basically, okay? So we're saying that it's greater than 0. Now let's go ahead and look and see what happens when I try to compile this program. And you can see that it compiled just fine because the assertion passed. The length of foo is greater than 0, okay? And I'll just run it, okay? So that is a compile time assertion. Okay, let's look at if we have a compile time assertion that passes and a runtime assertion that fails. Okay, you know what? Really quick, very quickly, let me just let me go ahead and try and trigger this so that you can see what happens at compile time when a compile time assertion fails. So as you can see, right, this is just very obvious. We are asserting that the length of foo is greater than 100, and it's obviously not, okay? So let me go ahead and compile this program, and we can see what happens. Now you can see, here's our file, error, static assertion failed. Now you can see this happened when I tried to compile my program, and it shows us exactly where the assertion failed. So that is a static assertion, or what's also known as a compile time assertion. This is evaluated when you compile your program, not when you run your program. Okay? Now let's go ahead and look at an example of if we have a runtime assertion that fails and a compile time assertion that passes. Let me go ahead and delete this, and let's say it's going to have to be something different. Okay, and let's assert that bar is equal to 1000. Okay, and I'm trying to show you also you can use underscores in your numbers for place separation, which is a very nice feature. It really helps readability. So for our static assertion that's evaluated at compile time, we're asserting that the length of foo is greater than 0, which it is, you can see. But at runtime, we are asserting that bar is equal to 1000, okay? And so this will pass during compile time. This will fail during runtime. Let's go ahead and look at that, okay? So let me clear my screen, and let me build this program. And you can see the compile time assertion did not trigger, so it compiled just fine. Okay, here's the program. Now, let's look and see what happens when I try to run this program. And you can see that the runtime assertion failed. Here's the file, the line number, and you can see here's our assert statement right here that so bar is not equal to 1000. This assertion tripped. Okay. Now let me show you one more thing that you can do with assertions. So say we can put a custom error message inside this assertion. And the way you do that is, so you have your expression that you want evaluated, and you have to separate this with a comma, and this is going to be a string. And this is the message that you're going to see when your assertion triggers. So let's say, I'll put this in all caps, I'll say we want to see this. Okay. And now, so here's our error message that we want to see. Okay. You can see the form of this. Okay. Now let's go ahead and try this again. Okay. Let me clear my screen. Okay, now let me build this program. And you can see that it builds just fine, right? Because our compile time assertion is passing. Now, let's see what happens when we run this program. And you can see it triggered our runtime assertion, and here's the error message. You see? We want to see this. So it's at the very top level, and you can see it right here within our assertion. This is a way to give yourself a custom error message when you trigger an assert statement. And you can also do this exact same thing with compile time assertions as well. So those are assertions. That's a runtime assertion and a compile time assertion. Please feel free to go back and watch this video, this portion of the video, if you need to. Hopefully that's clear. If you have any questions, feel free to ask in the comments, and I will try my best to help you out. Okay, now let's take a brief look at tagged unions. Okay, now let's look at an example of a tagged union. And this would be a tagged union. And what we're doing here is we are declaring a variable, foo, and we're saying that it can be either an int or a float 64. Now here's the thing about a tagged union. It can be either one of these types, okay? And we don't have to cast it. In some languages you can cast a type to another type, but that's sort of a special case. A tagged union is different, okay? A tagged union is saying this type can inherently be one of the, this variable can inherently be one of these types. Now we're assigning 42, and in Hare when we do that, it's assigning it the default type of an int, okay? So let's go ahead and just print this value out, okay? And you can see that it prints the value of 42. Okay, now let's go in. Let me create some space. Now, since this is a mutable value, okay, we're going to reassign a mutable variable. We're going to reassign a different value to it, okay? And let's just say, I don't know, 57.9341, okay, just something arbitrary. You can see, though, that this is not an int. This is not type int. This is going to be type F64. Now, let me go ahead and print this again, and you can see that it prints out the floating point value, okay? Oops, sorry, wrong thing. So in essence, that's what a tagged union is. You're saying here is an L value, so your variable, and you're saying that it can be one of these types, okay? Now when we come to error handling, these are going to be error types generally, but I'm just trying to show you what a tagged union is with very basic examples, okay? Now, let's go ahead and try and use the type keyword and sort of dig into tagged unions a little bit more. Okay, so let's go ahead and use the type keyword, which is already introduced, and I'll show you how that's used, right? You can use it to define structs, but you can also use it to define new types, new actual types. So we'll say type, and let's call this type text, because what we want to do is we want this to be either a rune or a string. Okay, now a rune is a UTF-8 character, okay? That's all a rune is. It's a character that's encoded in UTF-8. So if you're coming from C, think of this as the char type, char or string, okay? So we have a type here, which is a tagged union. The type is text, but it's a tagged union of rune or string. So type text can be either one of these types, okay? Now let's go ahead and we'll create a variable, and we want it to be of type text. We're going to use our new type. And let's go ahead and just make this a rune, okay, so just a character. And let's go ahead and just print this out. Okay. And you can see it prints our character A to the screen. Okay. Now, since this is mutable, let's say foo equals hello. Okay. And let's go ahead and print this out again. And so you can see what I'm doing here, okay? We have our tagged union, which is of type text, and we're declaring it to be of type text. Now, if we didn't do this, it would just be a rune, and you wouldn't be able to assign a new value to it, a new type to it like this, okay? So here we are assigning a new type, which is of type string, and again, it can take on this type because of this tagged union here. Okay, so let me go ahead and run this program. And you can see that it prints our character, or our rune, and then our string. Okay? Now, so hopefully that's kind of clear. That is essentially what a tagged union is. A tagged union is a value that can inherently take on multiple types, but those types have to be specified, okay? And it has to be one of the specified types, okay? Now let me show you an example. This is going to hopefully be pretty simple, but this is really going to prime you for handling errors with pattern matching and tagged unions in the next video. Okay, so hopefully this part is clear enough so far. Okay, let's go ahead. I know we haven't gotten into really using some of these language features I'm about to show you, but hopefully you have a little bit of experience programming, and in my opinion, Hare is a very readable language, so hopefully nothing that I'm about to show you will be new. I certainly hope not. If it is, please say something in the comments and I will try my best to help you out, or again, please feel free to rewind this video and watch it as many times as you need to. So what we're going to do is create a function, and we'll just call this return type, okay, because what this is going to do, it's going to return a value based on a type, okay. And let's just give this a basic parameter, and we'll say it takes type text, okay. So it takes type text. This function takes a tagged union of type text. Okay, now here's the return value. And this is where tagged unions really come into play in Hare. Okay, this is one of the most common ways in which you will use and see tagged unions, both in your code as well as in the standard library. And what we want to do is we want to say this can return either type rune or type string. Okay, so let's create our body, and what we're going to do is, let's say if, now we can use a form of type interrogation here with our tagged unions. Okay, hopefully this is pretty simple to understand. We're going to say if val, right, so our value here, that whatever argument we're passing to this function, if val is rune, okay, then what we want to do is return, let's say, just a rune character, R for rune, okay? And then we're going to say else, return string, okay? So again, if, and you can see this is a rune, okay, so this function can return type rune or type string. This is a rune, this is a string, okay? So if our value that we pass in when we call this function, which it has to be of type text, okay, which again is a tagged union here, okay? If our value that we pass in is a rune, we're going to return R, which is a rune, else we're going to return string, which is of type str, okay? Now let's go ahead and call this in our program somewhere, and we'll call that right here. So we'll say let bar, and here's going to be our function call, okay? So return type, and we're going to pass in foo, okay? And then what we want to do is we want to print what bar is, okay? Let me go ahead and remove this. So let's get an idea of what's happening here, okay? We have type text, which is a tagged union of rune and string, okay? we have a function that takes a parameter of type text and performs an interrogation on its type with the is keyword. And if the value that we pass in is a rune, we're returning R, which is a rune, which is going to be this right here. And if it's not a rune, it can only be a string because it takes a text as an argument. So, and then in that case, it's going to return string, which is this type right here. Now we're declaring foo to be of type text, and we're just assigning it to be a rune. So when we pass foo into this function here, it's going to be a rune. And you can see that it's going to return R when we print bar. So let's go ahead and run this program. Let me clear my screen. And you can see that it printed R. This is just a rune, okay? Now, let's go ahead and do the same exact thing, except let me go ahead and assign foo. Let me say hello. So foo is now a string, and you see it can take on a string because it's a tagged union. It's defined as type text, which is a tagged union, okay? And I can keep bar. I just need to remove the let keyword. Okay. And so we're just assigning a new value to bar. Okay. And let's go ahead and run this program. And you can see we first pass in a rune and it returns R. We then pass in hello as a string and it returns string. Okay? And so that would be right here. So what this function signature is saying is that this can return either a rune or a string. And this right here, what I just showed you, is this right here is basically, this is basically what error handling is in Hare, except we're using a match statement, and I'll show you that in the next video. But this is basically what error handling is. When you call a function, it returns a tagged union, and you are evaluating what type that function is returning. And if it's returning an error type, that's what you're handling, okay? So hopefully that's clear. Please feel free to watch this video again if you need to. I've tried to break this down just as simple as possible. I can assure you that the first time I started learning about this, I was bewildered. I was so bewildered. I had to go, there was the only resource that I knew off the top of my head to learn pattern matching and tagged unions was the Rust book. I knew that I had found pattern matching in there before, and so then I just started looking it up. It's a very common functional programming feature, and that's what I had to. I had to learn about pattern matching and tagged unions outside of Hare. Okay, and then I came back to Hare, and it's where I really became comfortable using them. I like the syntax of it. The point I'm trying to make is I've tried to break this example down as simple as possible so that when we get into error handling with pattern matching, hopefully this will be clear and you won't be trying to learn this also on top of the syntax of pattern matching, which when I first got into it, that was confusing enough. So I'm trying to sort of prime you to sort of lay a basis for the next video, which is error handling with pattern matching. So please go back and watch this example as many times as you need to kind of understand what's happening here, and also play around with the language. Okay, the only way you learn is by experimenting yourself and seeing what things are actually doing, seeing what you can and can't do with a certain feature. Okay, and again, the thing is that Hare is still in development. There aren't that many learning resources available for it. Which again is why I'm writing my book at an introductory level, and this is sort of the progressive steps that I take so that by the time you get to pattern matching, you're familiar with the concepts enough in order that you're not being introduced to multiple things at once. Okay, so hopefully that's clear. Please go back and watch this video again if you need to kind of grasp this concept. Um, and again, if you have any questions, please put them in the comments and I will try to help you out. Or again, you can, feel free to jump on the Hare users mailing list and get help that way also. So those are assertions and tagged unions. And this is going to really set you up to be successful for the next video, which is error handling using pattern matching. And I can assure you, once you master this right here, what I'm showing you, and then pattern matching, you basically have, 80 to 90% of the language mastered at this point. Okay, there are some other features, but I will say once you grasp this and pattern matching, you have the vast majority of the language down. And I would say at that point, you're really kind of comfortable enough to start using some of the other advanced features of the language. So I would say tagged unions and pattern matching are going to be the real hurdle that you're going to have to jump over in order to become comfortable with this language and use it effectively. And my experience, I I do not enjoy any other programming languages now because of how simple Hare actually is. This might seem complicated. I can assure you, once you master this concept, you'll be spoiled to the point where you might not even want to go back to programming in other languages because of the way they handle errors and things like that. So that's just my little rant about it. But I hope you found this helpful. And so in the next video, we're going to do error handling. So thank you so much for watching. I appreciate all my subscribers. And thank you so much and have a nice day.